So today we're going to look at three things. We're going to do significant figures, we're going to do scientific notation, and we're going to apply both of those to the ultimate thing that we're learning, which is conversions. So let's get started. Significant figures are actually used when you do measurement. In order to determine significant figures, you can choose to learn 5 rules, or you can do it my way, which is much easier. This right here is a map of the United States, as you can see, and you have the Pacific and Atlantic Ocean, which most people know what it is. So the P for Pacific stands for present, as in your decimal point. The A for Atlantic stands for absent, as in your decimal point. And here's your first rule. Rule 1. So it says, if the decimal point is present, you start from left to right. So as if you're going from the Pacific Ocean to United States, and you start counting with the first non-zero digit you encounter, and then all the other numbers after it are significant. So to look at this example, you would say first non-zero, going from left to right, is this 3. And then all these other ones are significant, which makes this 4 significant figures. Okay? If you have no decimal point, then you do the reverse. You start counting from right to left. And you start with the first non-zero digit, just like the other one, which would be this 3, and then all the others are significant. So in this case, 1, 2, 3 are significant, just like the one before. Now let's do a little practice. Okay, number 1. We have 3 significant figures because we have no decimals, so therefore we start counting from the 2. Number 2 has 2 significant figures because we started counting from this 4, because those 2 zeros are not significant. Number 3 does have a decimal, so we need to start from the 1 and go towards the last 0, and all of them are significant, so makes it 4. Number 4, all of them are significant. It starts with a non-zero, so they're all significant. Number 5, only the 7, 2, and 9 are significant, so that makes it 3. Number 6, none of these are significant. 1, 2, 0, and 9 are, so that makes it 4. This one has no decimal, so once again, we reverse the direction, going from Atlantic to United States. So first non-zero digit is the 8. That makes it only 1. With 8, we have a decimal, so we start from this angle. We start from the Pacific Ocean towards the United States. So this one and all the other ones are significant, which makes it 7. Number 9, we start with the 1. Even though these are zeros, they're in between something, so they're all significant, and even the last one. So these are 5 total. 10, we have 4, as you can see. 11 is 22, but we need to start from this direction because there is no decimal. And then the last one, number 12, they're all significant, so you have 6. So that's how you do significant figures, right? So now, you can stop if you want for a minute. We are looking at the next one, which is scientific notation. Where are you? Okay, there we go. That's the worksheet. I don't want the worksheet. They went away. See, this is what I was telling you. I need to stop it because I can't find it.
Go.
Okay, so we're going to do a little bit more practice, and I'm going to let you guys do usually be the ones that tell me the answer. So that one would be Atlantic or Pacific? Pacific, okay? So that would be 5 significant figures. This one, Pacific also, 4. Next one, that's Atlantic. There's no decimal. So we have only 5. Next one. Okay, so this is a scientific notation, but what matters here is not the exponent, it's just the number. So the number is 3. Next one is 2. This one is also only 2 because we have no decimal, so we start from the Atlantic. All right, so now that you've reviewed that, let's go and remember what it was like to do rules with when you do operations with the significant figures. There's a difference here because you have 2 rules. The first rule is the multiplication and division. The number of sig figs in the result equals the number in the least precise measurement used. Okay, so what does that mean? Use the lowest number of significant figures that is present, basically. So right here you have 6.38 times 2.0. That is this answer. But since we only have 2 sig figs with this one, that is our lowest. Our number, that is 12.76, has to be limited to 2 sig figs. So you place your imaginary cursor here and you say, is this large enough to make that 12 go to 3? The answer is yes, so you make it 13. And that makes it 2. All right? Here's some examples of calculations that you can look through later, applying that same rule. All of these have been put in there for you for later. Okay, so next we have another rule. This is the second rule. The second rule for significant figures in mathematical operations is addition and subtraction. The number of decimal places, notice that this time it's not the significant figures, but we want to look and focus on the decimal places. And here we want the lowest number again. Okay, so right here we have 1 decimal and 3 decimals. So when we add these, we're going to end up with this number, which is 18.734. You do the same thing. You put it where your 1 decimal would be, and you say, is this number large enough to make that 7 go higher? And the answer is no, and you cut it down to 18.7. Okay. Next one, so we should have just done sig figs, huh? Calculation is like this. Calculator will say that. The answer is actually only 3. Because 3 sig figs, but we're not focusing on sig figs. We are focusing on the decimal place. One more. And you keep looking at these and applying that rule until you complete all of them. All right. So the next thing is scientific notation. In science, we really deal with some really huge numbers. That is a mole. Do you want to sit there and count all these zeros? Nope. So we also have some very small numbers, and that is the mass of an electron in kilograms. What if I asked you, how much does a mole of electrons weigh? You would be going, I have no idea. Unless you actually switched it to significant figures. I mean, scientific notation. And that is what you actually need to be doing. Because you can input that many zeros into a calculator even if you tried. So this is the format that you need to focus on. M times 10 to the n. Okay, so m is an integer, or number between 1 and 10, and n is another number. So you have an example of 25, let's see, 2.5 billion, I think is what this is. So you're looking at, first of all, sig figs. This is why we looked at sig figs first. How many sig figs? 2. We have no decimal. So the first step is to insert an understood decimal point. Then count all the spaces and then write it in the form that I gave you before, which is m times 10 to the n. And there you go. Next one, have a smaller number. Now, how do you know if the number that you have is positive or negative on your exponent? If it's larger than 1, the exponent's going to be positive. If it's less than 1, the number's going to be negative. So follow the same steps. Of course, there is no understood decimal point because you have one. And then decide where your decimal point needs to be. Bounce it all the way down there. Rewrite, and there you are. All right, the exponent is negative because the number we started was less than 1. Remember that. All right, so now we have calculations to perform, like that mole of electrons. This is an addition and subtraction though. So we have this format, it needs to be in that format. When you have the same exponent, it's very easy. You just add the m part and then bring down the exponent. But once you don't have the number that's the same, that's when it gets complicated. That's when you actually have to change it. Like as example in this one. You can go one of two ways. Student A chooses to go this way, and that is incorrect scientific notation, so now he has one more step to do. And there it is. Student A did it wrong. So don't be student A, be student B. Student B actually chooses to move the lower one to the higher one. And when he adds it, it is in the correct format. And that is all we needed. So let's try it. Now these ones are negatives. Negative numbers are different from positive because the higher number you have, actually the lower you are. So you want to look at the -4 and you want to switch it. No, you want to switch -6, right? Because that's the one that's the higher, -4. So you want to make -6 go to it. So in order to do that, this is my trick. Everybody always gets confused with right and left, left or right. What I do is I say, whatever you want to do to this one, you do the opposite to this one. So if we want to increase that, you decrease this. Okay? So we're decreasing this one by 2, hence that increases by 2, the end part. And you add it, and there's your answer. Now, don't forget your sig figs. Since we are adding, we can only have 2 decimals, right? So it would actually be 3.50. And that is how you do scientific notation. All right. So we are now going to do some practice. We're going to write this in scientific notation, and you're like, well, that is already written in the proper way. Just remember, anything that you multiply times 10 to the 0, it's like multiplying it times 1. So in order to change that, you need that format right here, 10 to the 0. Okay, this one's 1, 2, 3. So it's 2 because there's nothing here, so it's only 1 sig fig times 10 to the -3. This one, that's 5. So it's 4.5, I'm sorry, 3.4. I'm not seeing it. So 3.4 times 10 to the